Hello everybody, hope you're all well and surviving these bizarre times and in rude health. Time for a video. What is this? This is an Amstrad CPC6128. Why am I doing a video on it? It needs tidying up. Why does it need tidying up? Because it's been surviving off of a mix of hodgepodge hacked power supplies. You know, you've got a centre negative 12 volts for the drive, a centre positive 5 volts for the computer, both are the same diameter. What could possibly go wrong there? I didn't have any discs and I still don't. So what I'm going to show you here is how I've modified it to run a Gotek with an OLED on a 3D printed bracket. Also show you how I've put a Bwack Saver in to stop somebody down the line shoving, you know, an unknown voltage into the 5 volt rail of the computer. And I'll also show you how I've wired in a Mosfet which protects it from reverse polarity. And the reason for that is that if somebody down the line went and got the power supply, the centre negative pin power supply for the drive, plugged it in somehow to the 5 volts for the logic, it will protect that. I'm going to show you how I wired up the Gotek with a kit I basically bought off eBay. Let's get on with it. Hooked up the power supply to my scope here, and I've just got the little dummy load thing. So basically I plugged in 5 volts at 2 amps. It's supposed to be 2.5 amps it claims. So that's on 20 millivolts per division, so it's 20 up and 20 down, so I guess it's 40 millivolts. Okay, so that's the LED, that's the speaker, that's the LED. We're not going to mess up with any of this or any of this. We're simply going to add this onto the end of the Gotek drive. We want to disconnect without damaging. Okay, so that's the data cable. This is the power cable. I'm at Sewer Electronics Co. And we'll put that in some anti-static bag and somewhere safe. This is a 3D printed bracket for the Gotek I'll be using. It's got a hole there for a screw. The existing screw that's used in the Amstrad is too short, so I'll swap it for one of the case screws, and that goes perfectly into the hole. And there's some drone tape underneath to stop it rocking around. So yeah, the case screw is the same. So I've just mocked this up. This is our adapter. And there are ways of doing this without the adapter, but to be honest, the adapter is about, I don't know, about $5 or something with all the power cables. And for the sake of going in and maybe damaging something here, and plus it's reversible, so it's keyed. It goes in one way like that. I'll just mock all this up loosely, and then I've put the power. So that's the data there, and then this is the power. Because I think the orange is 5 volts, and I think the red is 12 volts. We'll check that in a minute. Obviously, the Gotek doesn't need 12 volts, so that's why this is just basically missing off the 12 volts. Putting the 2 grounds and the 5 volts to the Gotek. Like I say, you can switch them around, but this just makes it easier to undo for someone in the future. As you can see, I've just mocked it up. We've got the Gotek here, and I've put the power cable in series there. So that sits nicely like that. That is the correct way around, so that when we put this together, it'll be like that. And the way to tell is the red line there is on this side, and it's got missing pins on the same side as the red one. What I've done is I've put bolts on the bottom to level it up so it sits flat, because before it was not sitting flat. This plastic's actually quite flexible. I'm just about to program this in my mess of a front room here. Just got the USB to serial adapter. Most important things are these 2 pins here need to be bridged to put it into boot mode, and then you've got TX and RX going to RX and TX respectively on the serial adapter, and then 5 volts on ground. White is 5 volts, ground is black. So then you go and select your COM port and open the COM port. It's on 7 there, and then you click connect and it comes up, link is up, and you click program. It says done, no units left, we can unplug it all and it's all done. Then remains is to take it out of bootloader mode by removing the jumper down here, and then taking all the connections off. Then you go and get the firmware, the update firmware. You put it on the USB stick. It has to be a blank formatted stick. You power it and press and hold down these 2 buttons for at least 2 seconds. What normally happens is this thing starts going a bit nuts. So I couldn't do that live because you've got to hold down both buttons while you plug it into the USB. So not enough hands. You can see when it's finished, it flashes and it kind of goes around in a circle. It says NFL, no file loader, or no files. Okay, so now we know that works, and we've got the no file on a loader on there. We can change the screen. I did try and change the screen before that, but it won't show anything on these OLEDs without the firmware on there. So I would advise to wait until you've flashed the firmware before you change the screen. So this is a Bwack Saver. It's designed for a Commodore 64. It's made by a guy named Bwack, funny enough, and he open sourced it. And I did a video on it in a C64, and it's designed to protect the C64 against a power supply that fails and starts rising the 5-volt rail. So I think it's about when it goes to about 5.35, 5.4 volts, it cuts the 5-volt rail. So the idea is someone goes and finds a 9-volt power supply, a 12-volt power supply, doesn't look, plugs it in. It's going to save the computer by cutting the 5-volt rail. Okay, so I've traced the power switch. Now it comes into this sensor pin here, goes down the track into the rightmost pin here, and then goes all the way up this wire to this side of the switch, and then when this switch is closed it comes all the way back to that side of this pin and then carries on down the board. How the Saver works is it's got normal power and ground in, it then checks whether it's over a certain threshold, and if it is below that threshold it lets the power out down the white wire. So how that would work here is that instead of the power coming back down this side of the switch, it would come down the red wire. This would obviously have to be grounded as well, and then the white wire would go back to this side of the pin. Okay, so now the power comes in, goes in the right hand pin, goes up this wire into the switch. When the switch is connected, it then comes out, goes down the red wire into here, the ground's picked up from here, and then it comes, if it's good, it comes out the yellow wire and goes back to where the switch was. Okay, this is going to be my attempt to explain this P-channel Mosfet reverse polarity protection. If you want a decent explanation of it, go on Afrotechmods site. I've only just learned it myself, and this is blind leading the blind, but here we go. This is a P-channel Mosfet. P-channel Mosfet will turn on when the difference between the source and gate voltage is negative. Okay, so the source is a lower voltage than the gate by between 3 and 4 volts. So the gate minus the source is minus 3 to 4 volts. Say, think of it like a switch. When that happens, the gate comes up and it will connect these two, and the current will go straight across, and there'll be very little resistance. There's also a parasitic diode across the top, and the reason that's there is to make the source about a volt less than the drain, and I think that's to kind of kickstart it. I'm not entirely sure. Okay, so let's assume that we all go happily along and we come along and we plug in the 5 volts. Obviously the 0 volts is at 0, the 5 volts is at 5, the drain is at 5, plus 5, the source is at plus 4, because the 1 volt drop from the diode is normally what it is. What's the source? What's the difference rather between the source and the gate? Well, 0 at the gate minus 4 volts equals minus 4 volts. Condition met. The difference is less than minus 4 volts. The gate shuts. This virtually becomes non-existent because the current's going straight through here, and happy days, the thing works. Now let's assume someone comes along and plugs in the wrong way round. 0, 0 still, so that must be minus 5 volts now. So what's going to happen? It gets a bit confusing. The drain's definitely at minus 5 volts. And the way that Afrotechmods explains it is, assume the thing was on, right? If the thing was on, this would be shut, which means that that would be the same as that, which would mean the source would be at minus 5 volts. Now this can only be on, however, if the difference between the gate and the source is more negative than minus 3 to minus 4 volts, and it can't be, because you've got 0, the gate, minus a minus figure. And that's always going to be 0 plus a figure. And 0 plus a figure can never be less than or equal to minus 3 to 4 volts. So the gate can't be shut, the Mosfet can't be on. That's the way he explains it. You know, it's semantics really, because this could be, you know, minus 4 volts, minus 6 volts. It's not going to make any difference. What's going to make difference is that you're adding, you're not subtracting. You're taking away a negative number. This is a ESC, an electronic speed controller for a drone motor. It's an old one, but you can see on the back here it's got these Mosfets. Looking up the datasheet, P-channel Mosfet, voltage gate to source, which is effectively the blocking voltage, and that's plus minus 25 volts. The voltage from drain to source can be up to 30 volts, so that's well within what we're looking for. The turn on voltage, the voltage gate to source threshold, it has to be less than -3. The amperage that the Mosfet can take all day long, it changes with temperature, but it's way within our 1.7 amps. What we need to know is how hot is it going to get. How hot is it going to get? It depends on something called the RDS on. And the RDS on is basically the resistance between the drain and the source, when the thing's on. But let's just take the absolute maximum figure in the data sheet, 21 milliohms at 5 volts and 10 amps. Now the power dissipation is I squared R, which is the current squared times the resistance. We know that the Amstrad is taking 1.7 amps, and we know that the RDS on of this thing at maximum at 5 volts is 0.021 ohms, which is the same as 21 milliohms. So if we square 1.7 and multiply it by 0.021 ohms, we get 0.061 watts. That's all this has got to radiate. I don't know if you can see the dot bottom left there. That's pin 1. So these 3, 1, 2, 3 are source, so they're all going to be connected. We're going to make a cut here, that's the gate, and then the drain's all connected. Okay, so you can see I've cut the pin there, I've cut the copper here and here to isolate the gate. This is the source, these 3 left, this is the drain. So they're all connected, this one's isolated off. So let's put this in circuit and see what happens. So the red is the drain, and that's going to the positive part of the power supply. Black is the source, and that's going to the load. The other side of that load is going to the negative part of the power supply. And the gate is also tied to the negative part of the power supply. Well, let's just power it up. And we can see that 5 volts, 2.2 amps, 23, 24. Touch that, no problem. I'm pretty confident that's going to stay cool. What I'm going to do now is switch the polarity, and let's do it, -12 volts. 0. Let's just do it on that. No flicker there at all. Not a flicker. I think we're good. I'm going to put the whole thing together. Power supply, Mosfet, Bwack Saver, CPC6128. Somebody comes along and goes, oh, that's a nice 9 volt charger, I'll plug it into the 5 volt line. It'll get through the Mosfet, but it won't get through the Bwack Saver because it's more than 5.3 whatever volts. Someone comes along and goes, okay, I'm going to take the center negative pin 12 volts and plug it into the 5 volt power supply. It won't get through the Mosfet. So I'll just do a quick test. The resolution on my power supply is not great, but I'm just going to quickly turn it up, make sure it cuts out over circa 5.3 volts, and then make sure it cuts out or doesn't let any amps or volts through when it's reversed. I've hooked it up here, so we've got the positive, comes out of here, goes into the drain of the Mosfet, comes out of the source, excuse the colour wiring, goes into the positive of the Bwack Saver, and then the safe line from the Bwack Saver comes out into the load and then back to ground, and then the gate from the Mosfet is tied to ground. So what should happen here is if I reverse the polarity, nothing should show on the multimeter, and if I go over 5.4 volts, should drop away. Let's see. Okay, so firstly with the correct polarity, you can see that I've got 4.17. That's because we've got a load on here, pretty heavy load, and that's going to heat up pretty damn quickly. If I just start scooching this up to over 5.4 volts on this end of things, you'll see it will let it go to 5.4 and then drop away. So come back again. There we go. Okay, so you see I've switched the polarity around. Exactly the same circuit. Now we've got nothing going to the, we've got no voltage across the load. And I can go all the way up to -12 volts. or effectively minus 12 volts because the reverse polarity, nothing across the load. So let's get that in the Amstrad. Okay, so here we are with the Amstrad back in one piece. A couple of things to note. I've put a bracket in here, which is just 3D printed to give it some strength once the drive's been taken out, because that was metal and it was relying on that. The screws that went in here are in the drive, so they will be missing from this. Just quickly cover some of the chips on the board here. CPU, that's got a heatsink on it. 2 ROMs I haven't bothered with. Sound card. Keyboard chip. This is the graphics chip, I think, and this is the gate array. These are the RAMs. This is the disk control chip. No clue what that is. This is the saver here. Just there you can see the Mosfet that I've put in there. I've just heat shrinked it, taped it down, cut a hole in the top to allow the heat out of the heat shrink. 5 volts comes in here. It goes to the rightmost pin here. These 2 wires are actually crossed over, or crossed over even. I've cut a 2 amp fuse in here because there was no fusing on this board. It must have been in the monitor. We come up this yellow wire, we go to the switch. When the switch is bridged, it bridges the yellow and red wires. The red wire goes into the drain of the Mosfet. Then the source of the Mosfet comes out and goes to the power in on the saver. The gate of the Mosfet is tied to ground. On the other side of the saver, it's got the safe 5 volts, which is coming out of this green wire, or yellow wire I've coloured green, and powering the rest of the board. So in theory, and I'm not going to test this because I don't want to tempt fate, and I don't want to ruin the board, but in theory, what should happen is, if we get more than 5.4 volts, the saver will kick in, and if we get any kind of negative voltage, the Mosfet will kick in. Okay, so as you can see, all back together and working. For type cat, you can see the loader come up, so the drive's working. If I change the button, press the button up and down, and type cat again, it's changed the disk. And if I run chuck, you can see it's working. So thanks for watching, take care, I'll see you soon. Cheers, bye.